Okay, let's say you have this question here. You want to find the length of the arc S on a circle of radius r intercepted by a central angle theta. So if I were to draw this, even before I know the measurements, I would see that I have a circle. I know the radius of my circle is r, and I know that there's an angle, central angle theta, and that angle theta corresponds to an arc of length S. So we all know the formula S equals theta r. That's a formula that you need to remember. I think it's very easy to remember because, it sort of makes sense that once r grows, S also grows, right? The larger the radius is, the bigger S becomes, right? So this is definitely bigger than the blue S. So it makes sense that you're multiplying r on that side. Same for theta. The bigger theta becomes, so if I make theta even bigger, right, it's even clearer that this S is bigger than the one I had before. So it makes sense that I'm multiplying theta on the other side too. So by thinking about it, I think this formula is easy to remember. The other important thing you have to remember is that this formula only works for theta in radians. So in this problem, you're going to see that we're given theta in degrees, and that's not what we want at all. So I'll even make this red so that you pay attention to that. So the first order of business then is to convert theta from degrees to radians. So theta is 240 degrees. So how you convert that from degrees to radians? You multiply that by pi over 180 degrees. Another easy thing to remember about this is that pi equals 180 degrees, right? Pi radians equals 180 degrees. So these two are sort of the same thing. The top and the bottom of this fraction are the same thing, meaning this is just a 1 in disguise, right? So all you're doing is changing units of measurement. These two sort of cancel out. The degrees cancel out. This is intuitively what's going on. And then the answer is going to be in radians. So I have 240 over 180 pi. Divide this. 24 and 18. They're both multiples of 6. So if I divide by 6 top and bottom, this is in radians, I'm going to get 6 times 4, 24. So this is a 4. And then 3 pi radians. So that's my theta right there. And that's what goes into my previous formula there. S equals theta r. R I know, so S equals to theta r is 4/3 pi times 18. That was given by the problem 2 in feet, right? So that is the same thing. I can cancel this. 18 divided by 3 equals 6, so that's 24, right? 6 times 4, 24 pi feet. So that is the first step. That's the first answer for the problem. I'm even going to go back just to realize there. So first express the arc length in terms of pi. We've done that, check. That's 24 pi, right? It's 24 pi. And next, you want to round your answer to 2 decimal places. So you do that by just using a calculator. So S equals to 24, you multiply that by 3.14, or just most scientific calculators have a pi function. And if you multiply that, you're going to get a 75.398 feet. But that's really 75.40 because you want 2 decimal places like the problem asked. So that is the answer for this problem there. That's how you find the arc length of a central of a circle, the arc length intercepted by a central angle theta in a circle of given radius.